take the problems on single electrode potential and cell potential. Okay. Yeah. This problem is similar to the previous discussed problem. Only the change in concentration is observed. Anyway, I'll take it this one once again. Here, a electrochemical cell is formed by consisting of a magnesium electrode, which is dipped. That metal is dipped in a 0.042 m magnesium hydride solution, and silver electrode in 0.35 m AgNO3 solution. So standard SEP means standard electrode potential of magnesium and zinc are minus 2.363 volt and 0.8 volt respectively. Represent the cell, write the cell reaction and calculate the EMF of the cell. You already know how we represent this cell. So while representing the cell, first you predict which electrode acts as anode and which one as cathode. Here, the silver electrode possesses a higher electrode potentials. See, Ag1 electrode that possesses a higher, that is 0.8 volt, whereas this minus 2.363. So silver electrode, that is Ag electrode, now act as cathode. You know, it possesses a higher electrode potential than Mg electrode. Yeah, so that's why silver electrode acts as anode. And now I consider the cell representation. How we represent the cell? So first you have to write a anode Mg bar Mg 2 plus. What is the electrolyte concentration of Mg? That is 0.042 m. The two electrodes separated by means of a salt bridge. Then cathode is Ag plus, where the electrolyte concentration is 0.35 m bar Ag. Now I can write the reaction. At anode, half cell reaction, anode Mg giving rise to Mg2 plus 2 electrons. So at cathode, that is Ag plus, that you know, it takes only one electron at a time. So we write it as a Ag plus plus electron giving rise to Ag. Simultaneous process, so that's why the second equation should be multiplied by 2. Now the cell reaction becomes Mg plus 2Ag plus in raised to Mg2 plus Ag. These are the second part, that is representation of a cell, cell reactions and half cell reaction. Now you have to calculate the EMF of the cell. Okay? To calculate the EMF of the cell, you have to take a Nernst equation. And you know the Nernst equation, how we represent E cell equal to E naught cell, yeah, plus 0.592 by N log concentration of reduction species by the concentration of oxidation species. And E naught cell, how we calculate? That is using the two electrodes. Silver electrode potential is 0.8, okay, minus of this one magnesium electrode, that potential is minus 2.363. I'll take the same one, minus 2.363 plus 0.0592 by number of electron transfer is 2, okay, then log reduction species concentration is silver ion concentration is 0.35, but while writing it should be the power, okay, because 2 electron transfer is observed, divided by magnesium ion concentration 0.042. Okay. Now here 3.163 plus 0. 0.0592 by 2. I'll take it as a 2 log. Okay, 2 log 0.35 divided by 0.042. Okay, so that is equal to 3.163 plus 0.0592 and log of 8.50. The final answer before the step 163 plus 0.0592 into log of 8.3, we get 0.9206. So E cell becomes equal to 3.2175 volt. Okay, this is the final answer that we get. So, Nernst equation we introduce E cell equal to E naught cell plus 0.0592 by N log reduction species by oxidation species. E naught cell is E right minus E left. Right electrode is a silver electrode, so 0.8 minus of minus 2.6363 plus 0.0592 by 2 log concentration of the silver ion, that is 0.35 to the power 2, because the reaction involves the transfer of 2 electrons. Then the final answer what we get is, after substitutions we will get E cell equal to 3.2175. Okay, now I'll take the next problem. Okay, here calculate the E naught cupricus, that is E naught copper electrode Cu2 plus bar Cu. What the given is E Cu2 plus bar Cu, that is given 0.296 volt. Also, the cupric ion concentration is given. Okay, here it should be 2 plus. Okay, Cu2 plus ion concentration is given, that is 0.015. Yeah. Okay, what is the difference you observe? So, in before I'll take first Nernst equation I'll write. This is for a single electron Cu2 plus. So I'll substitute, and the given thing is Cu2 plus per Cu is given 0.296. That is equal to E naught Cu2 plus bar Cu plus 0.0296 a log of 0.015. Okay. And here you can write E naught Cu2 plus bar Cu equal to 0.296. Yeah, 0.296 minus 0.0296 log of 0.015. 0.015. Final answer, E naught plus bar Cu becomes equal to, after substitutions calculation, you will get 34984. A cell is formed by dipping zinc rod in 0.01 m zinc sulfate or a Zn2 plus solution, and nickel rod in 0.5 m Ni2 plus solution. The standard electrode potential of zinc and nickel are minus 0.76 and minus 0.25 volt respectively. Write the cell representation, cell reaction, and calculate the EMF of the cell. Okay. Here, see, similar to this problem is similar to the first one. Okay. Here they given the two electrode potential. First you predict which electrode acts as anode and cathode. Both poses a negative potential, like minus 0.076 and minus 0.25 volt. So now you find among the two electrodes, which electrode poses a higher reduction potential. Yeah, minus 0.75. or minus 2.5. Which one is a higher electrode potential in this negative scale? This is a minus 0.25 near to 0 positive, and this is a minus 0.76. Yeah, that means here near to positive means this is a uh, highest that the electrode potential is high. Yeah, nickel possesses a higher electrode potential, whereas the other zinc possesses a less electrode. Nickel now nickel electrode that you know why it acts as an anode electrode. Sorry, why it acts as cathode as possesses a higher reduction potential. Higher. That's why it is taken as cathode. Once you know the electrode, cathode, and anode, you can able to represent the cell. Okay. Representation. First, you write anode. That is sudden bar, sudden 2 plus. They given the concentration, so I'll mention 0.01. Double bar, then Ni2 plus. Concentration is 0.5 m. Then anode reaction at anode, that is familiar one, zinc giving rise to 2 electron converted into zinc ion. At cathode, nickel takes 2 electron. Net cell reaction, sudden plus, sudden plus. Now is it clear? Sudden plus, Ni2 plus, giving rise to sudden 2 plus plus Ni. Okay, this is a net cell reaction. Clear? This is a net cell reaction. Now, the next one thing is you have to calculate EMF of the cell. Am I audible? Can you confirm? My slide is visible. My voice, is it clear?
Yes, ma'am.
Yes, ma'am.
Hmm?
Yes, ma'am.
Next, you have to calculate EMF of the cell. Use Nernst equation. E cell equal to E naught cell plus 0.0592 by N of concentration of reduction species by the concentration of oxidation species. Is E naught cell we can calculate using the 2 electrode potential minus 0.76, okay, plus 0.0592 by 2 or 0.5 by 0.51 plus 0.0, or I can write directly 5.3. This terms comes to the total comes 0.0503. So E cell is 0.5603. And this way we can able to calculate the cell potential of the cell. Now I'll take little different types of problem. Next I'll go to a different type of problem. Okay. So in this problem, you have to calculate the zinc electrode potential. For that, they given the EMF of the cell. Two cell they construct, their EMF is given. The one cell is constructed using zinc electrode and nickel electrode. Their potential developed is 0.51 volt, and the cell which is constructed using nickel and standard calomel electrode, their potential is 0.49 volt. The question is you have to calculate zinc electrode potential. Like calculate zinc electrode potential E naught Zn2 plus bar Zn. That means zinc electrode potential. If the EMF of this cell, that is zinc coupled with a nickel electrode, which develop 0.5 volt, and nickel if coupled with a standard calomel electrode, the potential developed is 0.49 volt. The given thing is the standard calomel electrode potential is 0.24 volt. Okay. They are not directly given the nickel electrode potential. Okay. In the first phase, you can observe. If you know the nickel electrode potential, then only you can able to calculate zinc electrode potential using a standard equation, that is E cell equal to E naught cathode minus E naught anode. By using this uh, equation, you can able to calculate the either cathode electrode potential or anode electrode potential or a cell potential. Okay, the two terms you should know. Here you have to calculate nickel electrode potential provided if you know the zinc electrode. Sorry, you have to calculate zinc electrode potential provided if you know the nickel electrode potential. But to calculate nickel electrode potential, they given one more cell that develops a potential of 0.49 volt. That cell is constructed using nickel and standard calomel electrode. From this cell, you can able to calculate nickel electrode potential. Okay, the first step is to calculate E. Okay, I'll take a standard electrode potential, that one E Ni2 plus bar Ni. Okay, how to calculate this one? Standard electrode potential of nickel electrode, and you know the equation cathode minus anode, so we can write E cell equal to cathode is E naught. In this cell the cathode is standard calomel electrode minus E naught Ni2 plus bar Ni, and you know the standard calomel electrode potential 0.24 minus E naught Ni2 plus bar Ni equal to E cell, that is 0.49. Okay, 0.49. Now E naught Ni2 plus bar Ni becomes equal to 0.24 minus 0.49, that is equal to minus 0.25 volt. Now you know the nickel electrode potential. You know the EMF of this cell. Okay, you know the EMF of this cell, that is 0.51 volt, and nickel electrode potential. You can able to calculate. Now you can able to calculate zinc electrode potential. The next step is to calculate E naught Zn2 plus bar Zn. Okay, now we calculate. There we take a cell, this one E cell. Now E cell equal to the, find out the anode electrode and cathode. Cathode is nickel, yeah. E naught Ni2 plus bar Ni minus E naught Zn2 plus bar Zn. Okay. So E cell value is given 0.51 volt. So we can write 0.51, that is equal to you are already determined that nickel electrode potential, that is minus 0.25 minus E naught Zn2 plus bar Zn. Okay, now E naught Zn2 plus bar Zn equal to minus 0.25 minus 0.51, that is minus 0.76. This way you can able to calculate the electrode potential of any other electrode. If you know the electrode potential of an electrode and EMF of the cell. Once again, I'll take this one. Here you have to calculate zinc electrode potential. The given the cell, that is zinc electrode coupled with nickel electrode, that time develop 0.51 potential. They are not directly given the nickel electrode potential, but they given the cell which is constructed by using nickel and standard calomel electrode. That time it developed a potential of 0.49 volt. And they given the standard calomel electrode potential. The standard calomel electrode potential is 0.24 volt. And you know the standard equation is L equal to E cathode minus E naught and the first how to calculate the nickel electrode potential. So in the second cell, the standard calomel electrode acts as cathode and nickel electrode acts as the anode. Substituting, you will get the nickel electrode potential. Once you get the nickel electrode potential, using that electrode potential, you can able to calculate the electrode potential of zinc electrode, provided if you know the cell potential when zinc is coupled with the nickel. The cell potential is given, that is 0.51 volt. Nickel electrode potential is minus 0.25 volt. So that the zinc electrode potential developed or observed is minus 0.76 volt. Okay. I shall move to the next one. Okay. Here, a problem is a zinc rod placed in zero point 1 m zinc sulfate solution at 25 degrees Celsius. Assuming that the salt is dissociated to the extent of 95%. At this dilution, calculate E naught Zn2 plus bar Zn at this temperature. Okay. See, they want to prepare a electrode using zinc rod and zinc sulfate solution. They take a zinc rod and that is dipped in a zinc sulfate solution, assuming that the concentration of that zinc sulfate is 0.1 m. But when they took a zinc sulfate and it is dissolved with a known quantity of solvent, that time the dissociation, they mix that salt mixed with the during preparation of solution, only 95% of the salt get mixed. Okay, assuming that the salt is dissociated to the extent of 95%, not 100%. If it is 100% dissolution takes place, dissociated, then you can able to get 0.1 m zinc sulfate solution. But here only 95% is dissociated. That means you are not preparing a electrode which contains 0.1 mole. You are finding or preparing a electrode which contains a zinc sulfate solution of 95%, dissolution of 95%. And that dilution, you have to find out that dilution, you have to find out the electrode potential. Here, one more thing is given, that is E naught Zn2 plus bar Zn is given, that is minus 0.76 volt. Okay. Now, here, the actual, our intention is to prepare a 0.m solution. So that is concentration of Zn SO4 is 0.1 m. That is our intention. But how much percentage is dissociated? Percentage of dissociation of zinc sulfate is only 95%. Therefore, you have to find out actual concentration of ZnSO4 in solution. How you find out? For if it is 100% dissolution take place, you can get 0.1. But here only 95% takes place. How much concentration you have to find? So 0.1 into 95 divided by 100. The concentration of actual concentration of the solution is not 0.1. It is is 0.095. Yeah. At this dilution, at this temperature, 25 degree, you have to calculate E electrode potential. And you can use the Nernst equation, E equal to E naught plus 0.0592 by N log concentration of Mn plus. Okay. So E naught is minus 0.76 plus 0.0592. Number of electron transfer is 2 log concentration of 0.095. Okay. Say after substitution, okay, you will get this way. Then final answer, you can observe E Zn2 plus bar Zn becomes equal to how much? So it's direct calculation. Okay, we'll get minus 0.79 minus 0.7906. This is the final. That is minus 0.7906. This is a you study the calculation of electrode potential. Now I shall consider how to calculate electrolyte concentration if you know the electrode potential of the electrode and the cell potential. Okay. Now the problem deals with the calculation of electrolyte concentration. Okay. Here the problem. So what is the concentration of nickel ion in the cell atom? It should be 25 degrees Celsius. Not 250, it is 25 degrees Celsius. If the EMF of the cell is Ni bar Ni2 plus Ni bar Ni2 plus double bar Cu2 plus bar Cu is 0.601 volt. Given nickel electrode potential is E naught Ni2 plus bar Ni. Okay, E naught Ni2 plus bar Ni is minus 0.25 volt and E naught Cu2 plus bar Cu is 0.34 volt. Okay. From this you can predict anode and cathode. Here the higher electrode potential is copper. So Cu for electrode now act as cathode. Act as cathode. Or you can predict based on the cell representation. Here right side it acts as a cathode. Okay. Now I want to detect the electrolyte concentration of nickel electrolyte. So I'll take this one. E cell equal to E naught cell. Okay, E cell equal to E naught cell plus 0.0592 by N log concentration of reduction species by concentration of relation species. Now, you know the E cell, or I can put what are the component given. So E cell equal to E naught cell plus 0.0592. Number of electron transfer is here. How many electron transfer take place? 2. Okay. Log. Which one is the reduction species? Copper. So this reduction species is Cu2 plus divided by Ni2 plus. Okay. Now the EMF of the cell is given 0.601 equal to, okay, you have to calculate E naught cell, E right electrode, cathode electrode potential 0.34 minus of minus 0.25. Okay. This becomes E cell term plus 0.0592 divided by 2 log of what is the concentration of cupric ion? The given 0.75. Instead of writing this nickel Ni2, I'll take it as A. Okay, divided by A. That is A is equal to the concentration of Ni2 plus. Okay. Now I can calculate this one. So 0.601 equal to how much it becomes? It is 0.59. Okay, plus 0.0296, 0.755 A. Okay. Now 0.601 minus 0.59 equal to 0.0296 by, sorry, 0.75 by A. 0.601 minus 0.59. So it becomes 0.011, yeah, equal to, according to that I'll calculate, equal to comes 0.0296 log 0.75 by A. Okay. Now 0.11 0.011 by 0.0296 equal to log of 0.75 by A. Okay. This becomes 0.3716, 0.3762 equal to log 0.75 by A. Is it right? 0.75 by A and log 0.316762. How much it is anti-log of this? Anyone?
2.3529.
How much? 0.23529. Yeah, 0.23529. So therefore, A becomes equal to 0.75 divided by 0.23529. So the nickel ion concentration 0.03188. Yeah. Okay, this is the final.